Um,
Shall we turn on our... Oh, okay.
yeah, I just read and okay.
Hi.
Well, you
Hi.
say
Okay. Thanks for joining today and giving us your time.
no problem at all.
Um, yes. So, like, we are really interested and have a couple of questions regarding the machine learning engineers, and we are very enthusiastic about to know how their actual working is going on in industries. So, we have some couple of questions. So, it will be great if you answer them. So, Maral, will you start with your questions?
Yes, actually, I want to say thank you again from my side, and I start to asking you a question about, can you please introduce yourself and briefly describe your role at PayPal, particularly how it involves machine learning?
Sure. So I'm Moin. Joined PayPal 7 years ago in 2016. And before that, I was working for Discover, the credit card company, as data scientist, ML scientist. And before that, I was finishing my PhD at ASU in industrial engineering. And since 2016, when I joined PayPal, after 4 or 5 years, I changed my track to managerial track. Now I manage a team for ML science. Like our team's name is GADS, Global Analytics and Data Science. So the team has two parts. One of them is analytics side, another part is ML side. I'm managing a team on the ML side for consumer products.
Oh, thank you. Perfect. So in your experience, how frequently do you find some kind of ML, SVM, KNN, linear regression, and logistic regression being applied in the real world at PayPal?
Honestly, because I also have more kind of a statistics background, SVM is not being used much in industry because of many reasons. One of them is being very expensive to compute, for example, a decision boundary, and there are some very theoretical kind of like a decision that you need to make in terms of like what should be your I don't know, like the decision boundary, like the degree and so on and so forth, the kernel trees and all these things. But we do use a lot for logistic. We do use a lot of logistic regression. Like we don't use KNN. We use something that we call it ANN, which is approximate the nearest neighbor. We do use a lot of deep learning models. We still use GBM. Yeah, I think that's pretty much it. Random forest, not that much. Yeah, mainly GBM, neural networks, ANN very recently, and it really like it has its own use cases.
Okay, thank you. And I have one more question, and then I pass it to my classmates. So, from your perspective, how important are the math and English skills in machine learning field, especially industry like PayPal?
I think English is gonna go more on the soft skills, right?
Mhm.
Because at the end, when you train a model, when you build a model, you should be able to present it. At the end of the day, each and every company, at least in Bay Area, they have 3 different teams, mainly working. I mean, from the ML side. One of them is the ML team, another one is engineering, and another team is the product, right? So products and engineering folks, like by product, I mean either the team who builds the platform for you to deploy your model or the team who is building the features. Like, for example, when you go on PayPal app, there is a team that builds the P2P send money to your friend feature, right? So that's that engineering team. And product, they are not that much of like, I don't know, like math or like I should say ML kind of and savvy people, right? So you should be able to sell your product to them, showing them that, hey, over a very simple rule, you can see some level of improvement if you apply for example, machine learning, right? So you should be able to, at the end of the day, you should be able to convey your message in a way that they buy it and you get their buy-in, and like they start implementing that. I think that's and then at the end, and also when you want to present to the leadership, then you need to have a very good I can say communication skill, not only English skill, but communicate, because we do have at work some native speakers that they're not able to communicate or convey their message properly. So it's mostly not, I wouldn't call it English, but maybe communication. And your other question was math. Math is very important because I can say the only difference that just a software engineer and ML engineer has is I think ML engineer should be much stronger in math and in the hard skills in math and statistics. So I think both of them are pretty important because there are like a decision points that you need to apply your kind of in math common sense and figure out what should be the way out of that situation.
Thank you. I pass to Yukta maybe to ask her question.
Okay, thank you so much. So I have a question like, so we write while in ML models, we write multiple ML codes, okay? So it does not deliver accuracy sometimes even after normalization and standardization case. So in that situation, what are the steps, the ML engineer takes in the real world? So do they add a new data, or is the data changed, or is the model changed, or how many models are tested for each particular data set?
That's a great question. So you said that like we have a data, we apply the model, but we don't like the performance, right?
Yeah, the performance is not what we expected.
Okay. Most of the cases, like assuming that you have done the whole pipeline correctly and properly, most of the cases you need to go back and do feature engineering.
Okay.
In like I can say, I'm talking mostly about something that we call it traditional ML, right? The one that you need to do feature engineering, not about, for example, LLM models that like you can just apply it and do some level of tokenization and stuff. In terms of changing the model algorithm, honestly, I'm not a big fan of that because at the end of the day, if you apply logistic regression, which is like a very simple, maybe one neural networks, you're gonna get maybe performance of 70%, for example. If you apply the most advanced techniques, you hyperparameter tune it, like you exhaust all the thing, you exploit it, you get to maybe, if that was 70, that this become like 75, 76, you're not gonna go out of roof by like just applying a more advanced kind of a technique, right? You can improve a few percentage point, but it's not gonna be a huge level change. I assume that you already fine-tune your logistic regression and you're not too off with the previous model. So with that being said, assuming that your data, something that we call a driver set answer, is correct, we go back and do feature engineering, saying that, hey, we don't have a good signals to detect this sort of, for example, let's call it MO if it's fraud, or this interest if it's recommendation, and then redo pretty much the whole process.
Okay, so there is no chance that you add new data or remove some data when the accuracy is not good, or
Adding new data, again, like because we do have a very standard process and it's not the first time that we do it. Yeah, maybe if this is the first time that we do a project, we might go back and revisit the data. We call it driver set, the driver set, which is sample of the overall data that we have, right? Because when you're talking about the big data, you cannot model on everything. Like we do take something we call a stratified sample. We take sample and then we apply the model on that. So with that being said, if it's a standardized process, no, we just work on feature engineering mostly. But if this is the first time, I think I can say it should be, I should have said that maybe case by case.
Okay. So there is like one more question. What are the current technical difficulties the ML engineers are facing in the industry, or specific to PayPal? It will also work. But yeah, what are the technical difficulties?
I think technical difficulty that we have today, and you can see it actually in Nvidia's stock as well. Like there is I think models are growing much faster than our hardware. Like for example, I don't know if you follow closely, for example, the Palm model from Google. They have over 500 billion parameters. So you pretty much need like a TPU. You are not even able to fit it on one GPU machine. Either you need to parallelize multiple GPUs, or you need to get a TPU from Google and load your model. Or even, for example, there is a model just released by by Facebook called Llama 2, which, like, even if you want to use Llamas with, if I'm not mistaken, 13 billion parameters, you pretty much need a very expensive GPU card. So I think the main technical difficulty that now ML industry is facing is the advancement in ML is much faster than the speed of development of hardware.
Okay. And while designing any ML model, are there any ethical consideration, like when it comes to data models, what are steps taken to address is the bias or some outliers or something like that?
Definitely, yeah. I think any company, I can say, in the US, especially, like, for example, the financial companies, they do have a big compliance team and legal team, making sure that, like, the model that we're building are not biased in terms of, like, a racial bias, for example.
Mhm.
And most of the time, the way that we handle it, we make sure that we do not use the features that they give the indication of, for example, race, age, gender, and so on and so forth, these sort of things. Like, we drop it from the beginning to make sure that we are not going to learn anything related to these sort of, and they call it, if I'm not mistaken, protected something. So yeah, like, for sure, like the mod, like, making sure that the model is usable by the, and it's not is usable, is under consideration. And like, many of the models that we build in PayPal, many of them, or if I don't say almost all of them, are being reviewed by legal team. Like, we need to, but it really goes by there are the tiers of the review that we need to go through. Like, for example, if it's a credit model, it's highly scrutinized models. If it's a marketing model, it's a little bit less, and so on and so forth.
Oh, okay. And so this last question from my side. So in your role as ML engineer, what is the thing which excites you more? Like, what is more interesting from your side? Like, what brought your interest to ML engineer? Or can you just share your experience on that?
I think the most interesting thing in ML, I can say, is the fact that something 1 + 1 doesn't become 2 in ML. Like, in software engineering, it's just a couple of for loops and the while loops, and like a if and else's and conditions and function that you write. And you pretty much, if you do functional tests, unit tests, pretty much you get it right. But in ML, it takes a lot of creativity, most of the cases, for you to come up with a solution which at the end of the day, your consumers like, right? So any product that the ML team builds, at the end of the day, is going to be consumed by, for example, in the case of PayPal, by PayPal consumers. And we need to make sure that we have very high recall and very high precisions at the end of the day. So I think that's the most intriguing part of being an MLE.
Thank you. I think next can be followed by other teammates, like maybe Sejal or Megha.
Okay. Hi, Mayur. I'm
Hey.
Sejal. So I have a question. That among supervised, unsupervised, self-supervised, or reinforcement learning, which problems appear the most in the industry, or which ones you have worked on?
I can say like 80% of the cases are supervised learning.
Mhm.
It's self-supervised learning. We do also do reinforcement learning as well. And case by case, we do also unsupervised, semi-supervised, and this sort of a thing, right? But I can say most of the cases is supervised and reinforcement learning that we work on.
Yeah. So, the reinforcement and self-supervised, like, can you share something on that? Like, what kind of problems are coming to the industry?
So for example, supervise any problem, like for example, fraud problem, credit problem, recommendations, all these sort of like models, they are supervised. Like we label the data and then we train the model and we try to, in a real, I don't know, production, try to predict the label. And for reinforcement learning, so we do build model, for example, taking the feedback of the consumer back into account. Like, for example, if we offer you something and you don't take it, the next time we're going to adjust our decision. So the rewards, like reinforcement learning usually have a reward. We don't have that. We don't use that much of complicated reward, for example, for this specific case that I talked about. But yeah, like we do use like a human feedback. I mean, consumer feedbacks back into the model, which we call it also reinforcement learning.
Okay, that's interesting.
Thank you.
I have one more question. We were studying scikit-learn and H2O. These are some libraries used. There's one more library, SparkML. So, which library among the three is most used in the industry? And have you used all the three? Like, which one is the best? And
Yes, I use all three. I think SparkML these days is the most I don't know, common one to be used because of Databricks, right? So Databricks is behind the Fed, and they have a very strong ML ops, like I don't know, solutions and so. And at the end of the day, we're talking about big data, right? And in the world of big data, you need to have like map reduce kind of like a solutions, right? The scikit-learn is all you have to fit it into the memory, and like most of the cases, real life scenario, like not all your data will fit into the memory, so you need to distribute your data and so on and so forth, right? So that's why scikit-learn is mainly, I cannot say all the cases, but I haven't seen many people uses that in PayPal for the real, like a big model that we train. H2O, we used to use it in 2016. After that, like, I'm sure that there are still some people using it, but we stopped using it because of some reasons. And we migrated or moved to, for example, at the time, XGBoost and TensorFlow and so. But SparkML, in general, PySpark is being used a lot now in PayPal.
thank you.
No problem.
I think Meghna can go next.
Yeah, hi Mohin, I'm Meghna Hegde. Like I have some couple of experience in this field of data engineering. So I have like 5+ years, I can say. So I wanted to know more about this machine learning so that we can excel a career in future. So some of my questions regarding machine learning were like, do machine learning engineers spend most of their time in data cleaning? So to be precise, can 80% of their time cleaning the data? Is it true?
It depends. Sometimes yes, sometimes no. Honestly, like even for PayPal, it really depends on the maturity of the track. If you're working on a very mature track, pretty much, or like for example, for PayPal fraud and in general risk detection is a very important field. So there are so many eyes on it in the company. There are so many controlling in place. So for the same reason, the data that we usually get for training the risk models are pretty clean. Like we don't have much of challenges with those data. But if this is like a very new kind of a domain, or then a domain that PayPal just got into it and so on and so forth, or any other company, I don't think this is really dependent on PayPal or another company, then for sure you need to take more hassles to clean up your data and make sure that your data is clean. Otherwise, I don't think, for example, the ML engineer at Google that they're training, for example, the ML recommendation for example, YouTube, I don't think they have much of cleaning data task. I'm sure that their platform is very clean and stable and scalable enough for them to get access to the clean data.
Yeah, so the machine learning engineers do the cleaning process, or like there are some analysts like data engineers who do the cleaning process?
It might be case by case. I don't know about other companies, but in PayPal, it's by ML engineer. We are in charge of getting the data, cleaning it, making sure that there are not too much of bias and so on and so forth in the data, and then start pulling features and training our models. So it's I think it's mainly on the ML engineer.
Thank you. So the next question was, how do you determine which machine learning algorithm to use for a specific task or project? Like there are many algorithms, right? So how do you decide that which one to choose? Like
Very
among the
simple answer: cost of the deployment. Deploying a logistic regression is much cheaper than deploying a name it like a GBM, right? When I say cost, it's not necessarily the cost of the monetary cost. Sometimes it's an SLA cost. Like for example, when you assuming that you are deploying your model in production, it depends on your use case. You might have up to, for example, 200 milliseconds, right?
Okay.
For you to compute the score. Like 200 milliseconds, that means 1/5 of a second. So if you can get the performance that you want using logistic regression, you can give back SLA to your system, so your system can be more scalable. So for the same reason, like it really depends. If you want to go for like a deepest neural network, sure, but like you need to prove that for the amount of money that you spend on the platform, for the SLA that you consume, you are gonna able to return back a good ROI to the company. So it's really like, for example, that's why actually I think, I don't know who asked me this question, but when like question was, when you try different models, like I personally, if I can deploy a logistic regression and give me, for example, just say, for example, recall of AD at, I don't know, precision of 90% or whatever.
Yeah.
And but if I deploy, for example, a very sophisticated, complicated neural network, getting like, for example, recall of 82%, I rather to go with logistic regression for many reasons. One of them is the one that they said, and another one, honestly, I'm not 100% sure if that 2% is just a data bias or it's a real kind of a performance of the model. So it really depends how much. It's a trade-off, I can say.
Okay, thank you. So, like if you have used SVM, yeah, I know like SVM is not being used. So if you have used any models which require a hyperparameter tuning, how did you approach it? And after deciding the hyperparameters, did the performance improve for any of the models?
Yeah, definitely. I think you need to make sure that you do enough hyperparameter tuning.
Yes.
No, I don't know what do you mean by improving, because sometimes like we need to make sure that we are not overfeeded, right, to the data.
Yes.
For example, usually the general practice is, hey, do as many epochs. For example, if it's a neural networks, do as many epochs as you can, and so on and so forth. But sometimes like doing a 5 epoch is enough, right? So yeah, like definitely we do hyperparameter tuning on any model that we train on. But again, honestly, I don't expect hyperparameter tuning is going to give you a level shift on the performance.
Okay.
Maybe this is my experience, so don't quote me, but maybe 5% recall if you're lucky. So that's why most of the ML engineer works on creating new signals or features than doing hyperparameter tuning.
Hyperparameter tuning. Okay. So the last question what I have is, so what is the expected accuracy in the industry for the model to get accepted or use it for the future? This is my last question. So is
Honestly,
there any expectation for the
answer,
accuracy?
no. Yes and no. It really
Okay.
depends on the use case. Like for example, if you are working on a recommendation, you might have a different benchmark. If you're working on, for example, fraud detection, you might have a different benchmark. But we always do A/B testing, champion challenger kind of experiments with a new model. I'm hearing my echo back, but yeah, I think it's coming from your. Okay, let me try again. Okay, now it's better. So it's I forgot my thoughts, but so it's just about, I was talking about, can you remind me?
The recall and precision about the model when it is.
Yes, okay, sorry. Yeah, so we do always, sorry, I remember now. We do compare, we do champion challenger. Like for example, we do have a model already in production, 99% of the cases. And then we just say, hey, well, now we have a challenger, which is a new model that we need to push. We do A/B testing, we do a ramping. Like for example, we start with 1%, we observe the performance, then 5%, then 10%, then 100%, and so on and so forth. So there is no specific benchmark say, hey, like you have to meet this number, but it's mostly champion challenger kind of comparison.
So is it like above some 70 or 80%? Like at least, is it like that for any of the model? There is no kind of.
It depends, like it really depends. It can be 60%, it can be 90%, it can be 95%. It really depends.
Thank you, Moin, for answering my question. So next Pranal will ask some questions. Thank you.
No problem.
Hi, my name is Krinal. I won't take much of the time because I only have like 2 questions to ask to you. And the first one is like, among all the problems you have solved so far, which was the most challenging one? And like, what model did you use and how did you tackle that task?
I think any model is challenging, to be honest. The most challenging models that we usually build are the first version of the models, to be honest, because again, like we need to do a lot of case studies, feature engineering, feature deployment, not only engineer. Like for example, when you create a new feature, we need to make sure that we deploy that into the production. So then every time that a new request comes, that feature is being computed and then being inputted to the model. So I can say any model which is the first version of the model is the most challenging one.
Yeah. And my second question is like, based on your experience, what do you suggest students, like for us, that what are the current priorities for students and what do you wish that you had learned or known earlier in your career as a machine learning expert that would be valuable now?
I think 2 things. One of them is make sure that you're going to become as strong as possible in coding. It's very important. I can say, if you want to work in ML industry, ML as an ML engineer, I can say 95% confidently that you cannot even get into the industry if you're not good in Python coding. And when I say Python coding, I mean, I don't mean really writing like for example, a basic Python. You need to get good in Pandas, NumPy, and all these libraries as well. That's one thing. The second thing is going back to, I think it was maybe Maral's question on English and math. I think really get deep into each algorithm, because like usually when we interview like candidates, honestly, we don't stay on the surface. We really get deep in the algorithms. Like otherwise, everybody knows the basics. Everybody knows supervised learning. Everybody knows unsupervised learning, and so on and so forth. But there are very less people that, for example, know how random forest really works, why it got designed that way, why GBM got designed that way, right? So these are the things that usually even the companies, when they want to interview people, they put those very theoretical people in front most of the cases to make sure that these questions are being covered. If you wanna pass an interview or so. And then when you go to the job, again, like most of the cases there are a lot of back and forth, and usually the people who are go-getter people, they succeed in the role. So that's also another thing. Otherwise, like you're not gonna shine your team and so on and so forth, and you can guess after that.
Yeah. Like just an additional question, like which will be the model that you refer? Like what is a go-to model, or which model is your favorite one?
Very honest, I don't have a favorite model. The cheaper the better.
Yeah.
So seriously, I'm not but there are different people, to be honest, that there are different stream of thoughts in industry. But when you work for a few years, like in ML industry, and you see ups and downs of it, then you're not gonna be, I don't know, maybe fool is a bad name, but you're not gonna be fooled by the name of the algorithm, but you're gonna just say, hey, if I'm gonna get a headache, because like, for example, assume that you have a model in production, and if the model breaks, that's gonna be your responsibility, that, hey, your model broke. And breaking a model can be a score shift, it can be performance degradation, it can be timeout, right? Timeout means the upstream service is not going to get back your model score just because you missed the SLA. You were supposed to compute the score in 200 milliseconds. Now it's 300 milliseconds. You could not return it back. So they're going to assume that there is no response, and that's going to be your fault, or your team's fault. So after passing the early years, then just say, hey, let me just have a model which works up to 99 or 95% of the expectations, which I can debug as well when it broke, and I can afford that in my platform, right? It can be a very deep, like for sure, like for example, OpenAI cannot have a logistic regression for ChatGPT-4, right? They have to have that model, but they have to have that model. I'm sure that they have done all these analysis and they saw that, hey, like I have to have this complicated model to get this performance. Something that I'm not honestly sure about, for example, Palm of Google, Palm 2, I think they call it, with 540 billion parameters. As you can see, they got into a hype and competition with OpenAI. They just pushed a very big model into production, which now they prove that the Facebook model is able to almost match the performance their model, right? So I think at the end, you're gonna do a lot of cost benefit analysis and see which one should be the one to take.
I guess those were all the questions which we had. I would just like to say that thank you so much for giving us your time, and we really appreciate it.
No problem.
Yeah.
Thank you, guys.
Adding one more question to Krunel's question. So, is there a way when you add two models work together for the same problem, like taking so what I mean is like taking, if an output of one model is given as an input to another model or something sequence like that?
Yeah, a lot. Because at the end of the day, then when you have like you should look at it as a graph, right? So that model, like for example, let's just call it component, the model that you said, that's going to become another feature for another model, right? Like even let's think about it this way, like we do have a lot of embeddings that the features go to the first layer of the model, the embedding is generated, and all the embeddings are going to be fed to the next. So yeah, a lot. I can say maybe almost all the models PayPal, they do have those sort of models.
Okay. And
but usually those models are light, right? Because you cannot run them in parallel. Yeah, they're sequential, so you need to make sure that they're light.
Okay. So last question for the day from our end, like any suggestions for new joinees or new engineers which are going to get in the market or something? Just few suggestions from your end.
Yeah, go and learn Python and get deep into the algorithms.
Mhm.
Don't scratch just the surface of all the algorithms, and try to go both wide and deep, because you never know what company you're gonna start working on. You're gonna start working at. So
Mhm.
like whatever that you're gonna read, or like read a lot of papers on ML. The industry is moving so fast, so just try to read as much as you can.
Okay. Okay. Thank you. Thanks for your time and thanks for joining us today.
No problem.
Thank
It
Thank
was
you.
really a good session.
Yeah,
Thank
it
you.
was great talking
Thank
with
you very
you.
much.
Yes. Thank you for answering our questions. It will
No
be
problem.
it was helpful for us.
Yeah.
Thank you. Good luck.
Thank you so much
Thank
once
Thank you
again.
so
Thank you
much.
so much.
Bye.
Bye,
Bye.
everyone.
Bye-bye.
Bye.